Now we're going.
Awesome. Welcome to week 8. I'm going to do problem number 1. It has two. What was it? Here. 1 second. Let me read the question. So we have 2 chromosomes, and one's can be inverted. So it's the same except for one's lowercase. The one that is lowercase is the inverted chromosome. So our top one is the non-inverted, while the bottom one is the inverted, and it's having a cross between S and T. So it asks us for the 4 products. So the top one and the bottom one are going to be normal. So that's product 1 and 2. But the 2 in the middle are going to have a cross exchange. So for product number 3, we're going to have an LMN dot OPQRS, but then it's going to cross down to TUVQPO dot NML. And that just means that there's 2 centromeres in product 3. Then product 4 is not going to have any centromeres. You guys probably did it the other way, but I just like reading left to right. So we have XWRS, and then we go up, we go up to TUVWX. So yeah, that's problem 1. It was pretty simple. It's the same as on our practice problems. Cool.
Okay, so for the second one, it says, just the fill in the blank one, it says non-disjunction in meiosis 2 produces 50% diploid gametes, whereas non-disjunction in mitosis can produce a mosaic phenotype. For B, the answer is paracentric inversion. For C, it's Turner syndrome. D is liver cells. E is Chat, something like that. And then type A, hemophilia. F is duplication, is what we put. And then G is the alternate segregation pattern. And so that's number 2. And we're going to move this here.
So I am in charge of question number 3. So A says, how many total chromosomes would be found in humans that have the following conditions? Turner syndrome, it would be 45 because it is -1. Jacob syndrome, it's +1, so that trisomy, I don't even know. So that's 47. Cri-du-Chat syndrome is normal, so it's 46. Familial Down syndrome is 46. Type A hemophilia is 46 as well. Which of the following terms is not associated with something Marie tooth disease? We got triploid, aneuploid, reciprocal translocation, trisomy, and non-disjunction. Which of the following terms are associated with Klinefelter syndrome, aneuploid, trisomy, and non-disjunction? And then D is which of the following terms are associated with type A hemophilia, and none of them are. So that's number 3. And we will move down.
Oh, perfect. All right.
Can I see the board?
You can just barely see the bottom. There we go. So for this one, for problem A, what we're doing here in this problem is that we're making a diagram of the synapses of chromosomes 1 and chromosomes in prophase 1. And so we put up the 2 things here, and we put this dividing line to show that's where the crossover would be. It's kind of hard to see, but it's going to be between F and G and then between O and P. And so that's where we're going to form the crossover event. And then for B, so all of these cells will be ×2. So for an alternate segregation, The purpose of it is that the chromosomes diagonal of each other are going to segregate. And so for the first one, we got D, E, F, G, H, centromere, I, J, K, L, and then M, N, O, P, centromere, Q, R, S, T, and then D, E, F, P, centromere, Q, R, S, T, and M, N, O, G, H, centromere, I, J, K, L. For part C, which is actually down here on the bottom row, it's going to be the adjacent one segregation, which is when the chromosomes on the bottom half separate together and then the chromosomes on the top half will separate together. So we got D, E, F, G, H, centromere, I, J, K, L, and D, E, F, P, centromere, Q, R, S, T, and then M, N, O, G, H, centromere, I, J, K, L, and M, N, O, P, centromere, Q, R, S, T, and cell 2. And then for part D, it's for the adjacent 2 segregation, and that's when the right half will segregate together on one side and then the left half will segregate together on the other side. So we got D, E, F, G, H, centromere, I, J, K, L, and M, N, O, G, H, centromere, I, J, K, L in the first cell, well, in the first 2 cells, and then D, E, F, P, centromere, Q, R, S, T, and M, N, O, P, centromere, Q, R, S, T in the second set of cells. And then on to question 5. Good job. Oops, sorry, let me switch. There you go. There you go.
Cool. All right, so number 5 is saying, it says cats have 38 total chromosomes. How many total chromosomes do we find in the following types of cats? The first one is triplet cat. And so how you find that is you just take 38, divide that by 2, and then multiply that by 3, and that gives you 57. For B, it says a cat that is monosomic for chromosome 12 would be 37 because you're missing one. A cat that has suffered a terminal deletion on chromosome 7 is going to be 38 because there's not adding or subtracting a chromosome there. A cat that has suffered a Robertsonian translocation between chromosomes 17 and 18 is 37. And E, a cat that has suffered a reciprocal translocation between chromosomes 6 and 9. Once again, you're not adding or subtracting a chromosome there, so you still have 38. And that concludes our video for this week.